Welcome to my Introduction to Networking course, typically abbreviated ITN. This will be for the CCNA version 7 curriculum.
Hello and welcome. This is Packet Tracer 14.8.1 TCP and UDP communication. So, first of all, read through the objectives. You have two main parts: generate network traffic in simulation mode and examine the functionality of TCP and UDP based protocols. Read the background so that you understand what's going on. And with that, let's go ahead and move forward. So, part 1. Generate network traffic in simulation mode. Bottom right hand side, you have real-time and simulation. Simulation mode basically allows you to do like a step-by-step so you can see the data flow through the network. So, we're now in simulation mode. Click on the multi-server and click desktop tab. That means the server up here. Desktop. Command prompt, and we're going to ping TAC in 1. That basically says send one packet to 192.168.1.255. So this is the broadcast. You're pinging the broadcast address to all clients. This command option will send only one ping request rather than the normal 4. That will take fewer seconds as every device on the network will request from the multi-server. If you do simulation, nothing's going to happen until you click play. And what is really funny is that did not do as expected. There it goes. I'm speeding it up, step by step. It's still reading, but here is the request from 1 machine, 2 machine, 3 machine, 4 machine. How do we know there's 4 machines? That's because there's 1, 2, 3, 4 clients all responding back to the multi-server. And if we go back, we can do this step by step. So, I want to pause so we can work through this. First thing is the ping process starts, and then the next ping requests. You'll notice source is our multi-server. Destination is all 255s. That is a specialized address, typically a broadcast address. We can see layer 2 goes to the switch. It is doing a straight F. That is what a broadcast frame looks like. Then it goes to the layer. And then the next layer will receive it on the switch. The switch receives it. I don't like the fact that it keeps doing that. So the switch sends it to the HTTP client, computer 1. The switch sends it to the FTP client, at which time the HTTP client happens to respond. DNS client gets it. FTP client responds. It finally gets to the email client. DNS responds. And an email client responds. So now we have our HTTP client receives it. We can see the MAC address and the quad F, we can see the ARP packet. We can see that for all three of them. So with this, the device takes out the frame from the buffer and then sends it. Here, the switch receives the frame on Ethernet 0, FTP client, the DNS client, the email client, and then we forward information to the switch back to the multi-server. Here again, it's receiving it on port 0. It receives the frame. The device takes out the frame and then buffer and then sends it. And we just keep working through it. You'll notice that this doesn't take seconds. Like, this is all in fractions of a second. So I want to get down here where actual responses. So for example, here's the switch at the email client. Again, it receives it, processes it. Here, the switch will take it out of memory, put it on the wire, and then it just works its way down. So that takes care of step 1. So step 2, let's generate some other type of traffic. So again, in simulation mode, we are going to go ahead and I'm going to reset everything. Generate some HTTP traffic. So go to simulation, HTTP client, web browser. We want to go to 192.168.1.254. Click on go. We can play it and it will go through the process, or we can do a step-by-step. HTTP client sends the requests. Let me organize the window a little better. To the switch. The switch, why did it send it to everyone? Because the switch, I'm going to assume, receives the frame and then forwards it out. Only the destination where actually has the protocol that has all of that traffic will respond. Again, we're not really dealing with IP addresses at the moment. We are dealing with MAC addresses because we are dealing with local traffic. The multi-server responds, and then the response comes back to the client. We're requesting more packets. Alright, so first HTTP. Then the switch gets it. So this is the switch taking it out of memory. This is the device receiving it. The server receiving the requests. And again, we're just working down the layers. So what's happening behind the scenes? Basically, we send a request over a specific protocol like HTTP. We send it for local communication. Local communication, i.e. the switch, receives the requests, and it has to send out an ARP request because it doesn't know who has that IP address. So it got sent to all the machines. Only the one that is listening for that protocol responds, and more specifically, matches that IP address. So it's not just the protocol, it's the IP address. The multi-server responds with the hey, that's me. That's my IP address. Here's my MAC address. Then they send out the requests for port 80, which will be layer 4, TCP port 80. And then it retrieves the website. And here we go. That would be the receipt of the website. We send the request, the server packages it up and sends it over. All right, that's step 2. Step 3, generate FTP traffic. I'm going to reset my simulation. FTP. We're going to go to the command prompt. From here, we're going to do FTP 192.168.1.254. And again, we're going to walk through the process. It will send the request to the switch. Switch doesn't know the IP address, so it sends it to all of the clients. So they're getting red X's because they don't, that's not them. This is essentially ARP. The multi-server does respond, hey, that is me. Gets it all the way back to the VPN client. From there, we send a request back to the multi-server. Now that we have the IP and the MAC address, we send a TCP port 21 request, also known as FTP. So here we are sending the request, source port random to destination port, IP address of multi-server, MAC address of multi-server. The switch receives it, forwards the frame on. So here the switch is forwarding it to the multi-server using port 21, protocol FTP. Multi-server responds. Switch responds to the FTP client. FTP client receives it. There might be more information that has to be there. We go forward. That's it. Data has been received. And there is our FTP request. So that generates step 3. Generate some DNS traffic. You're going to notice we're just going to do the same thing a few times. So we can see that this is how this works throughout each of the major protocols. Open a command prompt. NS lookup. Multi server.pt.ptu DNS query gets sent to the switch. Switch doesn't know what IP address that is, IP and port, so it goes to all the clients. All the clients go, nope, not us. The multi-server that is actually having it will respond. So I'm actually going to go back one. You'll notice here we have the inner layer. The frame destination MAC matches receiving port MAC. The broadcast address or multicast address. The device will decapsulate the PDU from the Ethernet frame. The packet destination IP address matches the device or broadcast address. It recapsulates it. And it goes through the process. And DNS is received, and that's the end of it. We receive a response. Step 4 is done. So the switch knows the IP and MAC address now. So why each time we go to a client is it having to figure out and send to the other machines if they're not valid. You'll notice they just get discarded. They don't belong to the conversation, but the switch should only forward that to the appropriate recipient. And that's something for a later video, but alright, so step 5, still in part 1, we're going to reset our simulation, mail client, open the email from the desktop, compose to user at multi server.pt.ptu, subject, this is a test, this is a personal email. We're going to hit send and move that out. So when I hit send, the email client packages it together, forwards it to the switch, switch sends it to everyone. The other 3 machines say this doesn't belong to me. The multi-server receives it, processes it, responds, sends it back to the switch. Now we have STP traffic going on, because that is the protocol that needs it to verify it. And there we go. So, step 5 done. Step 6, verify that traffic is generated and ready for simulation. There should now be a PD entry in the simulation panel for each client's computer. You'll notice I reset them after each time. So if I go back and I ping one of them, I reset the simulation, and so it was resetting the ARP. So that's why the switch actually never learned the information, the IP address. If I stopped resetting them, the switch would have actually retained all that information. As we went through it, we were actually doing step 7, examining the multiplex traffic as it went through. And we did this for each one. So, we want to look at some traffic. Question, or step 7A, forward capture until the PDUs travel through the switch. We've already done that. Capture forward 6 times and watch the PDU from different hosts as they travel on the network node. We've done that. What is this called? This is called conversation multiplexing. When we have multiple things going together, a variety of PDUs will appear in the event list. What's the meaning of the different colors? Different colors, different protocols. Echo responses for our web client. For example, they all mean different items. There it goes. I'm going to go back to FTP. And you can see once the switch learns the MAC addresses, they can stop doing the ARP requests. But if you reset the simulation, it does reset the memory. Alright, so that takes care of step 7 in both those questions. Let's go to part 2. Oh, actually, I'm going to go ahead and do all of these again. Mail client, compose, user at multiserver.pt.ptu. This is a test 2. This is a test. Okay. That way we have all the traffic so we can look through part 2. If we reset the simulation, it will filter the traffic will only be whichever one we're looking at. We can show all or show none. We can filter as well. You'll notice, I know it says click reset the simulation. So that's what I'm going to do. I'm resetting it so we have no traffic. The switch no longer has any information. We're going to edit our filter, and we want just edit the filter. We don't want any of them. Show all, show none. What we want is TCP and HTTP. HTTP, TCP. All right. Open the web browser. Let's do this again. We're only capturing and displaying TCP and HTTP traffic. So click forward until you see the PDU. The color changes. We already see that. Why did it take so long for the HTTP PDU to appear? That is because the TCP must first establish the connection so that HTTP traffic can begin. Remember, TCP is a connection-oriented, meaning it does handshakes. Click on the PDU for. We have our outbound PDU call. We can now see the header. Here's our TCP portion. Here's the Ethernet. Here's the IP. So here's the Ethernet header, IP header, TCP header, and then data header. For TCP, again, connection oriented, so we can see the source port, destination port, and the sequence details. Are these communications considered to be reliable? Yes, because we have a sequence and acknowledgement number, meaning they have to have guaranteed delivery. What are the source ports, destination ports, sequence numbers, and acknowledgement? Source port's going to be random. Destination port, port 80. Acknowledgement and sequence number are going to both be 1. If we do this several times, the sequence and acknowledgement number may be different. Here, one of the last ones, acknowledgement number is 103. So the acknowledgement number does increase. Alright, so F. Looking at the value flags, which is located next to the Windows field, the value of the right B represents the TCP flag that are set for this stage of data communication. Each of the 6 corresponds to a flag, represents of a number 1, and any of the place indicate the flag is set. More than one flag can be used. I'll go back to the first one. Zero B 0001100. That's flags. Here are flags. And then that's just data. Normally when we're talking TCP layer 4, that normally means looking at the flags here. What flags are set in this PDU? Flags that are set happen to be the acknowledgement 5 and push. And we have later videos covering the flags in HTTP variable more in detail. So close the PDU with a checksum return for the request. Click the envelope and select the inbound. Inbound. There we can see our headers. Click on the PDU, the source and destination. Source and destination. So this is still not the inbound. That's outbound. That's still heading towards it. There we go. Here's the actual response. You'll notice the ports are now reversed. And when we look at it, we're seeing that it's coming from the multi-server. How are the ports and sequence numbers different than before? Again, source to destination are reversed. And in the acknowledgement numbers 1, the flags have changed. Here, the flags have changed to a SYN-ACK. So 2, 5. Alright, so click the HTTP PDU with HTTP client has prepared to send to the multi-server. That's J. Oh, sorry, we're on I. Click the second PDU envelope and select outbound details. What's the information? The source and destination, we already said that. We got the ports as the response. That's what this guy was for. Reset the simulation. And we're going to redo this for each of the main protocols. FTP. I'm going to play. That way they do it in real time. I'm going to go ahead and do the FTP. this time, while it's running, I want to show none, and I want to modify and just do FTP and TCP. Alright, I'm going to pause now that it's done. Now that it ran through everything. Click capture for the second PDU. Are these communications reliable? Oh, I think it meant this guy right up here. Are they reliable? Yes. It uses TCP. Record the source destination sequence number. We have random source, destination, 21, and a sequence of 00. Alright, so close the PDU until returns to the client with a checksum. So they actually notice the checksum still 0. Checksum still 0. Still 0. Still 0. So it will be one of the later ones. Normally, we're going to be looking for our responses. Alright, so when we're looking at our response, you're going to notice the first one was source 1027, destination 21. Now this is reversed. You'll also notice the flags being set. Flags are SYN-ACK, and you'll notice the sequence and acknowledgement number now changed to 1. Click return to the FTP client, PDU, notice different colors. So open the PDU and select inbound. So this is actually the last one. Here is the FTP, FT response. This is the message that was received. Welcome to the FTP server. So that takes care of FTP. All right. Step 3, examining DNS. We already know we're going to hide everything but TCP and DNS. All right. From here, back to the command prompt, look it up. I'm going to let it play through for a minute. All right, so we've repeated the steps for DNS traffic. Why is there no TCP? That's because DNS typically uses UDP. So I'm actually going to reset it. Make sure UDP and DNS is enabled. And then I'm going to go through this again. looking at the OSI model, you'll notice layer 4 is using UDP. Are these communications considered to be reliable? No, they are not. Open the outbound PDU details and find the UDP section. So, layer 2, layer 3, layer 4, you'll notice source, destination, length, checksum. Oh, you know what? What's really funny is I was looking at checksum from the frames, not checksum for the TCP header. That just kind of threw me off for our previous one. So checksum is different than the checksum for the frame. This is a frame checksum. This is a segment or PDU checksum. All right, anyways, going forward, source 1028, destination 53. Again, there is no acknowledgement or any of that because UDP does not use them. Close the DNS client. Go to the last one. You'll notice ports are reversed because this is a response. Source is now 53. Destination is now the randomized port from the beginning. This is a response coming from the server. If we go down, we can see the DNS query. We are looking at multi-server, and the IP address is 192.168.1.254. This is the response. All right, that takes care of 3. Now let's look at 4. 4 says reset everything. I'm going to close some of the excess windows. All right. We're going to go ahead and show none. We want to enable TCP, SMTP, and POP3. You might also do IMAP if you're using an IMAP client, but we're not. We're using a POP3 client, so that's what we have. All right, so we're going to send another email to compose user at multiserver.pt.ptu test 3. This is the third test. Send. Play. Let it work through. Give it a minute. You'll notice it's using TCP. Communication is secure because it's TCP. We happen to know that SMTP is port 25. So if we do the first one, we can see source and destination. Source port's 1028, destination port is 25, sequence and acknowledgement number because we're using TCP. So yes, it's secure. If you go to an earlier email, source destination, you might have sequence numbers of a 0 if you go to the first one. So click the TCP UDP envelope and select inbound. So if we go to the first one where we have SMTP, we won't have an inbound because we're still sending data. You'll notice that the ports are flipped and the acknowledgement numbers have increased. The flags should be a SYN and ACK, and the acknowledgement increases. So I'm going to go back to this SMTP. you'll notice no inbound. Go to the next SMTP, still outbound. Go to the third one. Source destination, we're still using sequence 1. So again, this is setting up the TCP handshake. We looked at the destination. So the last one will be our inbound as a response. Ports have flipped. Our acknowledgement has increased. Again, at the very end, what email protocol they're associated with port 25. Port 25 is SMTP. Protocol associated with 110, that will be POP. So let's look at that. This is port 25. That means these are SMTP. I don't see any POP. Let's go and edit our filter. Alright, and it should have captured it when we emailed, and it's actually not showing correctly. Not sure why it did not capture any of it, but user at multiserver.pt.ptu test 4 fourth test. First ones are ARP. Not sure why it's not capturing the POP3 traffic, but sending of email is SMTP. Receiving of email is POP3 or IMAP. Alright, so that actually is, there is no assessment. That's the end of the lab. If you have any questions, please let me know.
If you have any questions or anything, please feel free to reach out. Again, with this material, being able to ask questions and discuss some of the topics in the lecture help build long-term retention, so do not be afraid to communicate with this topic. Again, I'm here if you need anything. Thank you.